The Excel file and the PowerPoint slides used for this lecture are available on my homepage under the CSE 2111 link, and they're also available on Carmen and Canvas, which is the learning management system used by OSU. Please follow along with the PowerPoint slides as I talk about each subject.
Financial functions are functions that can be used to calculate values based on compounded interest. For example, if I take a loan out for $5,000 and I want to pay that off in 5 years, what kind of payment do I need to make? If I have $10,000 and I put it into a savings account and it yields 5% interest and I keep that in there for 5 years, what am I going to have at the end of that 5 years? Before we talk about these functions, I need to talk about the concept of simple interest versus compound interest. Simple interest always calculates the interest based on the original amount. So for example, let's say we put $1,000 into a savings account and it's 4% per year for 2 years. Year 1, my $1,000 will yield $40 in interest. Year 2, that $1,000 will yield $40 in interest. So at the end of 2 years, I will have made $80 in interest, and I will have a total of $1,080 in my savings account. Compound interest always calculates the interest based on the latest amount. So let's take that same $1,000, put it into a savings account. I get 4% per year, but now it's compounded yearly. So I take that $1,000. At the end of the first year, I will get $40 interest. I will take that $40 interest and add it to the principal amount, which is $1,000. So now I have $1,040. Now I'm going to get interest on that $1,040, which will make my interest at the end of the second year $41.60, which will make my total interest that I get $81.60, and I will have a total amount of $1,081.60 in my savings account at the end of 2 years. When we talk about compounded interest, we need to talk about compounding periods. Interest can be compounded yearly, quarterly, semi-annually, or monthly. The total amount of your financial transaction will be different based on when the interest is compounded. So for example, let's say that we have that $1,000 we put into a savings account. This time we're going to compound it quarterly. That means that we will divide that 4% interest and we will get equal interest amounts of not amounts, but we will use 1% interest rate for 4 quarters, which will give us a total of 4% for the year. So the first quarter we have the $1,000, and again, if it is compounded quarterly, there are 4 quarters in a year. That's why I'm doing it by 4. So at the end of the first quarter, we will receive $10 in interest. We will take that $10 and add it to the principal for the second quarter, and then at the end of the second quarter, we'll receive $10.10 interest. We'll take that amount and add it on to make our principal for the third quarter $1,020.10. The interest at the end of that quarter will be $10.20 or 0.201. And then we will add that to the fourth quarter amount, which will make our interest approximately $10.30. And so at the end of the fourth quarter, we will have $1,060 and approximately $10,060.60. Let's take a look at this in a graph. If we put that $1,000 in the savings account for 1 year at the top, you see that, then at the end of 1 year, if we compound it yearly, we'll have $1,040 in our savings account. If we compound it quarterly, we'll have $1,040.60. If we compound it monthly, we'll have $1,040.74. Look down at the 2-year amount. If we put $1,000 into that savings account, after 2 years, if we compound it yearly, we will have $1,081.60. If we compound it quarterly, we'll have $1,082.86. $1,000.86. If we compound it monthly, we'll have $1,083.14. Now, the financial functions that we're going to use in this class are the present value function, PV. That's what you get or pay at the beginning of the financial transaction. The future value function, or F of V, is what you're going to get or what you will have to pay at the end of the financial transaction. The payment function, or the PMT, is going to give us the payment made each period, which has to remain constant over the life of the annuity. The rate function is going to give us the interest rate per period, and the NPER function is going to give us the number of payments per period. Excuse me, let's go back. Actually, the number of payment periods, excuse me, the NPER function is going to give us the number of payment periods. I said that incorrectly. All right, here's the syntax for all of the functions. Notice we have a function called present value. In the present value function, we have a rate argument, an NPER argument, a payment argument, a future value argument, and a type argument. But if you notice at the bottom, we also have a function called rate. And the rate function has the arguments that you see. What you want to realize is I'm going to give you some rules to follow, and I will tell you whether it's rules for the arguments within the function or rules about the function itself. The first rules I want to tell you about is if you look at the bottom, the rate function and the NPER function, you will multiply the rate function, the entire function, whatever answer you get from that function, you will multiply it by the number of compounding periods always. The NPER function, you will always divide that entire function by the number of compounding periods. Let's talk about arguments in financial functions. We're not going to talk about the functions themselves, but we're going to talk about the arguments within the functions. The first argument is the rate argument. The rate argument is the interest rate per compounding period. For this argument, you will always take the interest rate and you will divide it by the number of compounding periods. The NPER argument is the number of compounding periods. For this argument, you will always multiply the number of years by the number of compounding periods. The PMT argument, or the payment argument, is the periodic payments to the initial sum. The payment cannot vary in these functions. So if you're making a $50 payment, it has to be assumed that you will be making that $50 payment throughout the entire life of the loan or the investment. The PV function is the present value function. It's the original value of the financial transaction. The FV function, the FV argument is the value at the end of the financial transaction. And the type argument designates when payments are made. If you put a 0 in for the type, we will assume that payments are made at the end of the period. If you put a 1 in, we will assume that payments are made at the beginning of the compounding period. For this class, let's back up. 0 is the default. And for this class, we will always assume that payments are made at the end of the period unless I tell you specifically that they are made at the beginning. When you're using financial function arguments, you need to use consistent signs for your dollar amounts. If you have outgoing cash, you will use a negative. If you have incoming cash, it will be positive. We consider outgoing cash anything that's coming from your pocket and going to another entity. For example, if I have $10,000 and I'm going to put it into a CD for 5 years, for this function, I need to put in a negative number because it's coming out of my pocket and going to another entity. On the other hand, if I get a loan for $15,000, then for the function, I put it in as an argument. For the argument will be considered a positive number because that's money coming to me. Even if it's for a minute, it's money that's coming to me in my pocket. Now, for arguments that are 0, at least a comma must be put in the function to maintain the argument order, unless no other non-zero argument follows. So, for example, I have the PV function here. I have an argument of 0.03, an argument of 2, an argument of 0, an argument of 5,000, and another argument of 0. My third argument in that function is a 0. Therefore, I don't have to put that 0 in there. I can just put a comma in as a placeholder, and the function assumes that that's a 0. Likewise, if I have zeros at the end of the function, I don't have to put those zeros in.